next 17 minutes. Yes, hi.
25.
Well, I picked a performance talk for some reason, because the actual reason is we just survived our holiday season. You know what the holiday season is? Did I say we survived the holiday season? Yeah, good reason, the season. Well, holiday season is basically Black Friday. That's the day after Thanksgiving. It's not very German, but Thanksgiving is a public holiday in the US. So, and it's in November, last Thursday in November or something like that. And so all the Americans go shopping because they have a free day, but the shops are, no, they're not open, but the Friday after the Thursday is a free day. So they go shopping, they do their Christmas shopping. So it became traditionally the peak day of sales. And then IT came along and made an IT Monday, what is Cyber Monday after it. So we're in retail business, so we were kind of scared of that thing. And this is how we survived it. So performance is a topic that follows me, and I really love it for the last 22 years or so in IT. And I think it's one of the most underrated topics in IT, and it doesn't seem to die. It seems to be actual all the time. And basically, I want to give touch a couple of ideas, provoke you, hopefully, so that we have some reason to talk afterwards with beer. So first, I will touch performance. It equals money and success. So good performance is good money and good success. Then I will talk a little bit about load tests and show one of the bugs that we uncovered. I will have to look at external systems. We need to look at data growth. Variance of traffic is interesting, peaks. And last but not least, cloud performance, because we're all in the cloud and everything is fine now. I thought so. Ha, bloody ha. Okay, let's start with money. And how do we start with money? I made a little video here, and accidentally, while making that video, I sent a message to Stefan on Xing. Hi, and then never explained that was last week at nighttime. And so Stefan asked back, what did you do that for? And I said, oh, sorry, this was a mistake. So what I do here is I take out my mobile and I buy a bicycle on Otto.de. Otto is one of the shops I worked at. It's a cool place, really good architecture, very performant. And now you see, wow, the search, I just entered bicycle. That was so fast, you might not have seen it, but the search answers in 3 seconds on a bicycle. I looked for Stefan at Xing. Xing is faster, it's almost twice as fast. It's only like 1.4 seconds on Xing to find Stefan Tilkoff. Xing is the company I worked before, that's why I chose the two. And I always refer to Xing a bit as not so innovative and Otto as innovative, but somehow Xing did a better job in being fast on the internet. So why is that important? I mean, Xing was really fast, 1.4 seconds, that's like from now to, that's 1.4 seconds, 3 seconds. So is that fast? Does it matter at all? And yes, it matters. When I was working at Otto, we actually measured the performance. We did something like real user monitoring. Have you heard of real user monitoring before? Stefan has, he nods. You should have heard about it, because usually in the old days when we did performance monitoring, we always went to the operations people and they looked at their systems and said, it's all green, it's all fast. So they looked at their IT systems. But seriously, this is only the very end of the consumer taste. So what I mean by real user performance is actually a user who clicks something and gets a reply. And the time from click to reply, I would like to measure. I would actually like to measure even more. I would like to measure what happens in the brain of the user. Now, we don't have any sensible brain interfaces yet on our iPhones, but you can do the real user monitoring simply. There's even an API in browsers, and we should measure that. So at Otto, we had something like a 2.5 seconds average performance over the whole website. Very good measure. And the lines here are deployment lines. And at the right side of my monitor was the number of euros per minute. So Otto ranks here at 8,000 euro per minute. 8,000 euro per minute. Imagine that. If you had a hollow tube where 8,000 euro per minute goes through, this is Otto. Now always imagine I could take the tube and put it to my washing tub just for 10 minutes. Come on, give me 11 minutes and then back to Otto. That's really great. I mean, and that's the way Otto works, e-commerce. Totally fine, great business. Could finance 300 developers. And of course, then that happened, a deployment line. The answer time went up, skyrocketed, out of the monitor, came back like 90 minutes later, and the euros per minute, they dropped. And they did it again in the afternoon, and it dropped again. So of course, this doesn't make Otto very happy. It's also a good indicator. I mean, with this here, I was much faster than the admins. The admins didn't know at that time that the system was broken. And the team kind of knew they were already working on it. So really, the monitoring gives you more than just how fast you are, but it's a good measure of how you violate your users, how you bore your users out, because I talk with one word every 3 seconds. Is that fast? No, it's not fast, because what we require is 2 words per second. Otherwise, if I talk slower, you think I have a brain damage or something like that. And then the interesting thing is Otto actually measured it. They knew that the average, if they by 0.1 second faster, they never published that number, but they told me, and I was there. 0.1 seconds, that's 1/10 of a second. If you accelerate the average real user monitoring time, and if you're €2 billion business per year, you gain 10 million euro per year in plus in revenue. There's a direct correlation at Otto between performance and business value. So with our project, we did the old system, or I was not supposed to say what the old system was. It's an insider joke. And we accelerated by 1 second. So figuring that, we would have done something like 100 million per year. It's kind of true. The faster you are, the more business you make. And maybe some of you remember internet searches in the 90s, Alta Vista, and people always say Google was so good because they had this context search. I just found what I wanted to look for. But I think the simple truth is they were just faster. Alta Vista took like 5 seconds to come up with a very elaborate answer. By that time, I was already brain dead and asleep. So do real user monitoring. And of course, everybody nowadays does real user monitoring, and we know exactly the performance. It's one of our biggest key factors in UX. Bloody hard. I rarely see companies that do that. And we are not very good either in that, but we will become better. Now, isn't that a nice bug? It's a real bug. I took a photo of it. I took it off the dog and put it under the camera. It didn't survive that very much long after that. Anyway, but that's what you do with bugs. You kill them, right? Okay. So what I show you now is a graph, and I show lots of graphs. This is a load test done by René Schwitzke. Actually, Stefan, do you know René? XLT, Jena-based company. This is the guy that provides the software that was used at Otto to do the load tests for Otto. So if you don't want to use JMeter, because that's really hard to configure, and want to do load tests with Java programming, they have a almost open source solution for that. They'll give it to you. Yeah, I think there's some, they'll give it to you. Ask René, you can use it. So this is a load test. And I think we went up to 100% for 11 minutes, and it looks good. It was performed on our platform just before the holiday season, and pretty much the same load test the next morning looked like this. So what happened? And I asked René, it's really pretty much the same load test. So why did it work the evening before, and why didn't it work the next day? Any ideas?
User behavior.
No, good. It could be user behavior, but we don't have so much users on that. Not enough yet, so we should have more users. It's not the users that broke it. Simple fact is, we configured our platform in AWS with autoscaling. And of course, autoscaling at nighttime goes to sleep, shuts down all the systems. And then in the morning comes along the load test, and they pretty much thump the platform. And the autoscaling takes time to respond. Our platform seems not to give AWS the amount of time needed to autoscale up, but runs into timeouts beforehand. Shows red things. Of course, for the holiday season, the solution is simple. You switch off autoscaling, you keep the systems warm all the time, you pay 50,000 euro. That's actually the whole talk. Yeah, no, but that's clearly something you don't want. I didn't know that before, and I've worked in operations for a long time. I'm not a cloud guy, but anyway. But just this is one of the things that we learned. Auto-scaling might be slower than you needed, but why, for heaven's sake, did we program our platform in a way that the timeouts are so short that they don't wait for auto-scaling to come along? But we revealed more things. So the other thing we revealed was we use a lot. I can explain it in a minute. We use in the load tests. We used a lot of resources, or somehow the system seemed slow, although we already threw a lot of resources in it. But by a lot, I mean a lot, like a lot of Raspberry Pis. You know, if you put up the Raspberry Pi equivalent on this table, it would have been massive. And we're not doing that much business. We're good in business, but I mean, seriously. I mean, people were able to, on a Raspberry Pi, you could do a Moon challenge in the 70s. In cloud times, we can't do that anymore. So one of the things that we read was a nice bug. Tobias Pauling looked at our Go code, and this is one pull request that he issued in November, just before the holiday season. If you look closely up here, he removed something which is called defer tool consumer lock unlock. So obviously we had some sort of locking mechanism where we protected some resources by lock setting and lock unsetting. And when we looked into that, it turned out that it was probably from ancient times, like 3 years ago. So we already, one of the learnings is we already have Go legacy code. And he removed it because he proved with a little test program that he spun up 1,000 instances of that. Oh, and I have to say, this is a shared library, another anti-pattern. We have our own shared libraries. Not very good. But anyway, we have these shared libraries. So if you spun up 1,000 systems, the whole thing took like over 8 minutes to proceed and collapse again. And after he removed the lock, it was like 12 seconds or something like that. So it was like a 37 times acceleration. So that's why we called it the number 37 bug. And then, of course, we fixed it. But as said, it was in a shared library. So it was compiled into our 108 microservices, or at least in some of them, in the Go ones. And of course, before the holiday season, we didn't want to exchange all these microservices and redeploy them. Because if you have microservices the way we have them with shared libraries, they have been deployed at some time, and they work. And if you redeploy them, you're not so sure what kind of code you pick up with the next compilation step. So you should have some time of looking at it, whether it works fine, whether it integrates nicely. So you're kind of careful in front of the holiday season. So we managed to repair 2 of these microservices. And the other thing is we're still not sure about, and Tobias has to research that, we're still not entirely sure what actually caused this prolongation, because we didn't see a lot of raise in CPU time. We didn't see a lot of rise of memory consumption. It was just fucking slow, and it blocked somehow. So I think there's another timeout problem behind that, so we still have to investigate it. But okay, we fixed it. We don't know what we fixed, but somehow we fixed it. And we hopefully roll it out to the rest of the microservices. What we clearly learned from that is our Go code needs fixing. And in the talk I just gave this afternoon, I used this as a metaphor. This is, by the way, a very nice metaphor to go to Amdahl's law about utilization of parallel computers and parallel processes. And then I applied it to organizations, because if you apply Amdahl's law to organizations, you go to verticalization, independent processes, or independent, if you take a team as a processor in an organization. So that's why it's down there as well. René Schwietzke said, when I threw him that slide, the real learning on a technical base here is, which applies to many languages and frameworks, concurrency is hard. Only a few people do it right. Avoid anything at all costs that gets you into the lock or synchronization game. Share nothing rules on a technical level. Don't think you can do parallel processing because it's hard. People do PhD theses on it and still mistaken. But Of course, here, load tests nowadays are, of course, part of our deployment scheme. And when we deploy new services, we load test them all the time. We can easily do that. Who of you does load tests in the deployment chain somewhere at all? Not one. And it's kind of clear. It also doesn't show up in the test pyramid if you do the ISTQB thing. Then they always say, well, this is non-functional. This is non-functional testing. That's not what we're concerned about. So 20 years later, load testing still is kind of an orphan. Anyway, I think we should also look at external systems. Next chapter. So what do we do at NewsStore? Basically, I tried to make an architecture diagram. It's probably wrong. Basically, we have tenants, and tenants have systems, like they have a financial system, they have an order system, of course. They probably have warehousing, and they probably have objects to sale. And then we take all this in and bring some stuff back, have a big cloud with lots of microservices, and it all ends up on your mobile phone. And then you can have your whole retail business on an iPhone and go through the store, and you can pick up, you can do all the logistics. And if a customer comes, if Stefan comes, I can sell him new shoes and say, well, you also want to buy a jumper, and we all do it here. Oh, the jumper is not here. It's somewhere in Hamburg. No problem, I order it for you. Jumper gets to you magically by some parcel service. And you can all do that on your phone. Brilliant, isn't it? So this is what we optimized for the holiday season. Haha, this is not true. We only optimized our cloud. We had no ability to load test the tenant systems or their Shopify integrations. We even have a reporting engine, small company from Hamburg with an M and an O in their name. And we completely forgot to tell them that it's holiday season and that we don't do many deployments, and maybe they should also be a bit careful with their systems. So in the middle of the holiday season, they did a nice deployment and ruined the platform. So we tend to forget about external systems. And we tend not only to forget about it, this part, the left part, was really stupid. We could have, I mean, this is one of these things where afterwards you just go like, why did we forget it? But this stuff here is really hard, because none of your tenants have a load testing system that you can easily integrate and load test your system with. And then which configuration do you want to use? So it's also difficult. Yeah, why did we forget to tell the company about our holiday preparations? Andreas, why did we forget that? Because I forgot it. Yeah, we just did. And how could we involve other systems, external systems, better into load tests? Well, yeah. Of course, nowadays we have test systems also for the integration of our customers. And who of you have, do you have customer, or do you have external systems? Well, we do. And we don't do a good job in testing them. And it's also hard. I wouldn't even know how we could do a good job, but we kind of ignore the problem. We say, oh, it's kind of hard to solve, so let's do something different. So we could become better in that. Look at data growth. How do you like my mushroom photo? I had a phase in my life where I photographed mushrooms. This is a particularly nice mushroom. And mushrooms grow fast. They really, you know, you go there in the evening, no mushrooms. You go there in the morning, mushrooms. Like atomic bombs. Here's some data growth things. These are our transactions per second. This is not a lot, like 40 transactions per second. This is some graph of some of the things. So 40 transactions per second is pretty much nothing. It's easy. So something changed here. There was a spike. What was that? Is Enrico here? No, it's not here. Who knows from Mr. what that was? Just before the holiday season, we changed database. Of course, database changing has a migration involved, so we just changed it. That was a brilliant idea. It was actually a good idea. It accelerated us by a factor of 2. But really, seriously, 2 weeks before the holiday season, change the database? Well, it's all in the cloud. It's just like changing from MySQL to Oracle, what we did there. Or, you know, I don't know, some cloud database. I was seriously a bit concerned that we did that like 2 weeks before. It went well. We told nobody about it. If that went wrong, that would have been a nice head chopping exercise with our customers then. Well, it would have been my head probably. So. And there's another curve. 1 terabyte of data in 2 years. That's our data growth. So 1 terabyte of data, that's not so much, is it? It's okay. Terabyte, that fits easily on my MacBook, so I think that's fine. Probably it's twice as much because we do have backups and we do have also a message queuing system, which is also backed up, so it's probably 4 times as much, but still. Yeah. It grows. With growth things, you should always look at the slope, because with the slope, you can already guesstimate where it will end up. Could become big. And yes, I want to go to that. But I have been at a company in gaming. I didn't find the data, unluckily. I didn't store the data. I should have robbed them of their data. But I remember that I made a metric. This was after Xing. And Xing was really always good with data. They didn't store so much, and that's why they were so fast, because they don't store images, but only text. So I calculated how much data is stored per user on Xing, and I did the same for this shitty little gaming company who did online roulette games. I think probably this was a mafia scheme anyway, but they stored each and every game for reasons in an Oracle database and wondered why everything went so sluggish. And I think they had like 100 times the Xing volume of data per user for gone games. So look at data growth. And one of the principles that really is bad about data growth is, I think, CRUD, create, read, update, delete. That's HTML verbs, at least the important ones. Is that right, Stefan? Did I say that right? CRUD, that's create, read, update, delete, right? That's true. And that's HTML verbs, right? That's the language.
There's SQL. So, yeah. There's no reason. It's a stretch if you meant.
Sorry, HTTP verbs. That's what I meant, not HTML.
No.
It's
map it completely wrong. So.
Okay, listen to Stefan. He's the guy with the knowledge. But the thing that I observed was, in product development, we never do that. I mean, I learned once you should do all of that. I would expect to do delete, because if there's delete, then I can make a nice load test with JMeter with my notebook, and I can just create users at Xing. I could do some updates on the data, and I could delete them again until I was told this is a bad idea, because if you delete users at Xing, you kind of, at that time, you kind of fragment our user database in MySQL, so don't delete it. So I was not allowed to do it. So the tests that I couldn't write proper load tests because I couldn't use delete. When I came to other companies, I found out that delete should not be implemented because it's not important. You create users and they're never deleted. This is tomorrow's problem. Sometimes they're not even updated. So if you implement a CR platform in product development, you will have a lot of data growth eventually, and you will never have time to do the deletion because basically the product pressure will not give you time if you don't implement it. And the other thing which you can't do is nice testing schemes, because for proper tests you want to create your own data, test with your data, delete your data again, and the platform should be the same as before. What's that called? I keep looking for the Wiederholbarkeit von Tests. Yeah. Repeatability, no, but there's a word for it. So it's easy to collect big data. Actually, do you recognize the guy who says that? And this was 1951. Business guy, consultant, Cuba, America. 11 years later, the guy coined the phrase, it's hard to delete. Easy to create data, but hard to delete. So we should not wonder about data growth. So that was actually both times the revolutionary here, Che Guevara. You can look it up in Wikipedia, it's true. Variance of traffic. Yes, variance of traffic. This was a nice one from Xing. That's like over 10 years old. Do you recognize? Oh, well, it's written here. There's the usual, this is the SSL connections at Xing, and usually in the evening, people are not so busy anymore, they go to sleep. They go to sleep they don't go to sleep. They do something for 45 minutes, then they have a break, and they do something for 45 minutes again. So this was Germany-Spain, the soccer game. So you can see funny things in data. This one here, this is Otto, and Otto has a nice weekly cycle, and then they have a sales thing, they sell something, and you see a peak. This is thanks to Guido Steinacker. So you have to account for variance of traffic. Black Friday at New Store. This is our Black Friday. This is like Friday. This is the Thanksgiving. Lots of dead birds in that day. No shopping. Wednesday shopping. Tuesday, Monday is a bad day. Sunday is a good day. Saturday is an even better day. But Black Friday is a really good day in sales. So this is the number of orders created per tenant or something like that on Black Friday. So we had here also ×3 variance of traffic on the big scale. And on Black Friday, of course, you don't want that. You don't want cold systems that get hit by a peak. So how do you account for peaks? Well, I remembered an old Swiss friend of mine from, well, he had a company and he's basically an engineer, but a mechanical engineer. And he said, do it like in elevators. He always talks about the 3 times security. So we figured out on Black Friday, we need to work for like 10 orders per second. So I said, I'd like to scale the platform up to 30 orders per second. Cost us AWS money, but we had 3 times security. This is actually the elevator with which you entered the building. It will carry 13 people, 1,000 kilograms, but this is a German elevator. I am pretty sure it can carry 3 tons before it seriously gets stuck or disrupted or before the cables kind of go kaput. So in Europe, you have this kind of...
It's harder. 39 people? Harder to do, but probably possible.
Yeah, but you never know. I mean, there was a television series where they put like 12 people into a little trabi or something like that. So people do crazy things. So they jump in the elevator. I tried to find a picture of jumping in elevators on YouTube. This is really hard to find. One of the videos that is not on YouTube is people jumping in elevators. I think there's one, but you know, they immediately scream and are scared. So I don't know why they don't film that. So, okay. Of course, all our systems are designed like elevators, 3 times security buffer. We survived the holiday season at high cost with a not so super system. We'll do better next year, and we're working on doing better already, but we survived it. We didn't hurt our customers. So in that respect, it was a success, but it also revealed a lot of bugs and things where we could better, and it cost too much money. So cloud performance, now it's all good. We already saw that it's kind of hard to scale in the cloud. So, and I want to say something to that. Maybe I'm getting it totally wrong. And this is something about microservices as well. This is why I will hit Eberhard Wolf tomorrow in the face. And they said, you were wrong about microservices. I always do that, and he hates me for that. But I actually like the guy. He's really great. So I was at a company working. This was a bank, I think. Oh, no, this is this company, 110 microservices. And then I think, what is it? What did I calculate? I thought a Go or Python microservices would average out maybe at 22 megabytes. If you time that out, you come up with 22 gigabytes. Or the bank I was working at, they had Java microservices. The biggest one in lines of code was 10,000 lines of code. And the service was called Deployer. And it was in Java. So I thought, I'm an admin, I'm not a Java programmer. So I thought, aha, somebody programmed rsync in Java with 10,000 lines of code. And they compiled it, and it went up to 800 megabytes, because with J2EE, that's the standard size at that time with the Sun framework of a microservice. If you time that with 25 microservices, that was what about they had, and deploy it on Sun cloud infrastructure, which is actually not existent anymore. Well, it exists, but it's not being, it has a kind of zombie life. You also end up with 20 gigabytes. So it seems if you have microservices on some sort of small or medium-sized project, you always end up with 20 gigabytes. Now, how of you knows what the biggest MacBook, the most expensive MacBook is able to provide you in memory? Just came out? 64. Before that, 32. So we realized at New Store, it's kind of hard to run all this infrastructure for development on one MacBook. Of course, there's a solution for that. It's a cloud solution. And with Kubernetes, you can nicely throw all the microservices somewhere into the cloud and just pull off the ones which you're working with and what you want to deploy. And that's really neat. It's super. But it has one caveat. Have you ever heard this heater fan in a cloud? So it's always fast. You don't experience as a developer size or speed anymore. This is something I like about Go, actually. It compiles really nice small, and it cross-compiles, and I spent some kind of, a couple of years ago, I spent some time with children, with Raspberry Pis and services on Raspberry Pis, and you can nicely, I get the hint, you can nicely cross-compile Go code to Raspberry Pi binaries and rsync it over. You don't need an 800 megabyte Java service for deploying that. You can just use the shell command rsync, and it neatly works. So what I want to say here is I think we kind of lost a sense of, and it's really hard to gain as well, a sense of what do we actually need, or how resource intense are we? How big is our footprint? So I took my footprint because it's one of the biggest I know. I have a pretty large footprint in every respect. And I would vote for smaller footprints. So 800 megabytes for the smallest compiled JVM microservice. Yeah, I was all about that. The sound. Yeah, I like the fact that sometimes the fan starts because it tells me I did something wrong. Takeaways. End of the presentation. Good performance is real money. Load tests real problems. Do them. Well, I always did JMeter, but I think this XLT stuff is better, and probably there's even better solutions out there. External systems might be your problem. We experienced that. More data kills performance. Like one of the things that was really weird was that even on testing, we spent like, I know a company not so far from here that spent $18,000 on log data. Just on log data, seriously? Variance of traffic, of course, is super important. Spikes may kill you. René proved that. I like this 3 times security buffer, but seriously, I'm not sure whether there's any intellectual reasoning behind for that. I just took it because a Swiss guy said you have to have 3 times security in Swiss engineering. So, okay, do something, multiply it by 3, and then take care that it also works. Microservices become elephants after deployment. So it's micro elephants sometimes. And of course, the question, why did we not do all of this in advance? I mean, now is January, holiday season is 9 or 10 months away, so we could do it now. But I bet we will have better things to do, and we will come back to the topic next November. And then I'd invite you to the next talk, because we will have more customers, more traffic, and survive again. So, but my thing would be, for everybody to take away, we should do more load testing. And it's actually really fun because you find real bugs. So we survived it. Thank you.
Almost 70 minutes, almost. So now we cut a bit the time for questions. No, just kidding. Do we have any questions for Hannes? Oh, Olli.
Yeah, thank you for the talk. You mentioned early on you had this Go code which caused you problems, and it was actually a shared library where you said this was an anti-pattern. Did I understand that correctly? And you had problems because all the, say, 100 or so, or maybe only like 20 services that used this shared library, it didn't pick up the changes, and there was some drift, etc. So, and you only ultimately deploy 2. So in an ideal world, what's your ideal situation to deal with this piece of code and these 100 services?
Well, first, no shared libraries.
So you copy the 100 lines or so across all
do something
services?
different or use open source, but don't do your own shared libraries.
So, but how does it still, you have the problem in 100 services. How do you fix it then?
This is interesting. And I bet Stefan could say more about that. But, you know, seriously, part of these shared libraries are being, because we have an event bus, and this is just providing the connectors to the event bus system. So you could argue, why do we have an event bus? Maybe this is also not such a good idea. If you had services, you could also, on a macro architecture level, just say, or define, or agree upon, how do these services, how should they communicate? And then each service provides its own method of adapting or providing to the other service. Why should we have a shared library just to provide this very thin layer of interfacing to a standard system? You don't need a shared library. You could just program that any way you like.
But then if you duplicate this code 100 times, and you have a problem in the logic, you still need to fix it 100 times.
Well, first, I doubt that you actually duplicated it 100 times. Secondly, you could agree in your team context to, if you want to do it in some way, then just do it, agree upon in your team how you want to do it. Then it would be in a microservice level. It would still not affect a mistake in one of these libraries would not be as dangerous as an essential one. And the idea of shared libraries is always, if we do a shared libraries, we save a lot of work. We make the world a lot easier. But you have to maintain them, make them stable. You have to fix bugs. And I just learned, I didn't know that beforehand, I wasn't aware of that at least, then even if you fix the bugs, it doesn't mean that the bug fix enters your live code. Because for that, you would still need to recompile your code and redeploy it. And
yeah, that's what you have.
Other areas in the platform where I clearly know that just picking up even a new version of open source software is something we don't like to do because we don't know all the side effects that might have.
Okay.
Well, Johannes, maybe on the same topic. I'm kind of more back then, you know. I think there is a necessity sometimes for shared libraries, and it makes sense. And if you hit the bug in an open source library and exactly this bug affects your 100 microservices, you have exactly the same situation as you had before as you built the library yourself, right? So on the other hand, I know that we as computer scientists, we are so used to, oh, redundancy is so bad in third normal form, we need to normalize everything. And I think with this new type of architecture, we need to rethink this bit and accept this supposed redundancy, yeah, but I would not condemn, like, you know, shared libraries as the super no-go, to be honest.
Yeah, well, they do it extra. Of course, you will always have shared libraries. The thing is, I think the pendulum is tilted very much to the Russian puppet building of let's build another abstraction layer, let's build a library, let's provide something for.
I totally agree with that, right.
Okay, first of all, maybe a comment on this open source discussion, just because so basically we do a lot of open source ourselves, and then also you have a larger user base, you're also intrinsically motivated to not break the API and so on. So I think that's a good idea. And the other question is, how long did you prepare for Black Friday? And was it the second time, the third time you had Black Friday? Because I didn't follow up.
It was the second time with real users of significance into Black Friday, but we grew a lot in the last year, so it was bigger. And we kind of prepared from July onwards, but preparation is also product building. And from this, and we had a kind of awakening in October. I have to admit that. That was the factor 3.
I have a question in regards to load testing. You say that it's part of your deployment pipeline, and like whenever you deploy, you make a load test. But like a load test shows like real results when you have like normal traffic on the platform. It will behave differently when you make a load test against like a website which has traffic, or like you make a load test against like kind of a test or like a CI system which is normally empty.
This was of course a lie. We don't do load testing. There was a sarcastic after. Of course we do load testing. But it was so small print that you couldn't read it, and I didn't pronounce it right. We don't do load testing. We're not good enough in that. And I don't think.
I don't think that it's also like you get really good results out of load testing when you want to prepare for like a BFCM situation. Like you can prepare like the performance of the individual like a component or system, but like it will always behave differently under like regular load. And then if you had then you have a spike on it, like your system do crazy things which you never will see when you do it against like an empty kind of system.
The thing that really astonishes me with load testing is that really the first time I really saw a problem was 1999 at Lufthansa when we implemented an SAP component for Lufthansa Technik, maintenance, routine, and overhaul, basically aircraft maintenance. And it was crazy. The whole thing exploded in our face. We immediately went to Frankfurt, Kelsterbach, to the data center of Lufthansa. We had a war room with Oracle senior experts, with SAP senior experts, with Lufthansa senior experts, and we were sitting there for 2 or 3 weeks trying to solve the worst problems. At the same time, material was piling up in front of the workshops, but the people in the workshops were not allowed to use it because there was a proper process that had to be taken to put the material through the systems to make sure for the Luftfahrtbundesamt, which is the guiding regulation office, that these parts were valid. So I remember times where in Frankfurt, you would have one A320 at night time, the next A320 at night time, and both of them were at the minimum of their spare part list, which basically means one more part that fails and you cannot fly it anymore. And at night time, the mechanics was cross-swap the parts that were, so in order to kind of equal out the spare parts. It was crazy. And then I thought, like 2005, I thought load tests are over. I mean, this is a solved problem, but it's not. It comes back all the time. It's one of the things that regularly comes back. So this is really what I'm on about. I find it fascinating that we still talk about performance problems.
Other questions?
Yeah, I was interested in that you say we should delete data. I think that goes kind of against what people do right now. As I was saying, event sourcing is a big thing now, which is basically just piling all the transactions you had in your system, like logging all the transactions and then computing the current state. So you would say this is like a wrong way to do that, and you should like only, let's say, keep the minimum of data you need.
Well, if you collect data, you will have a hard time to delete it. That's what I say. If I'd like to invite you to a management meeting of any given organization, it could be Newstore, by the way, and just propose to delete old data. Just propose it. Just try to, just say, I will, this is old log files. Can I please delete it? And you have the remove -rm rf statement already in place. And can I hit enter? Try. There is a natural boundary between yourself and the enter thing, and you will not be able to hit enter.
I get it.
Only if you do it accidentally.
Yeah. But then, do you need to delete at all?
I don't know, but I just wanted to state that we are data collectors without reason.
Okay, good.
And the system, the product development system prohibits deleting data. And this is a wonderful business case for cloud operations.